Yeah, welcome to a short presentation about some effort that we've done in collaboration with our partners, the QT company, about how to integrate voice services, modern semantic voice services into applications. You may have heard of Integrated Computer Solutions, the company I work for. We're doing a lot of UX services and implementation works, mostly in the automotive industry, but also a lot of work in the medical device industry. And we're sort of, long-time QT fans, and a lot of people will ask themselves, well, why are you actually interested in voice? Isn't that something completely different? Over the last couple of years, what we have learned is that all of the successful projects that we worked on had one thing in common, is that they started from understanding the requirements from the UX perspective. So we started developing our own philosophy of saying, okay, before we actually go into an implementation of an application for a customer, we want to actually always make sure that we fully understand, and that the customer themselves, that they understand how the user experience is shaped, what the user is actually going to be doing with the application. That should be the beginning and the end of every project. And because we're talking about user experience, it is actually natural that voice is now, because voice is getting so much stronger, and because the technology behind voice, semantic voice recognition, has gotten so much stronger, that this technology is now playing a larger and larger role in applications. We're not seeing it replacing a touchscreen application. There's always going to be a mix of visual and audio feedback or audio input into applications. But what we do see is that when you're designing interfaces, when you're designing the UX, that you have to nowadays take into account the possibilities or the requirements that voice commands are going to be needed. And there are many applications that you can imagine. A surgeon in an operating room could give a voice command much easier than taking both of his hands out of the heart of the patient, right? So you can see where this is going to be playing a major role. And one of the things that's really important is that this is going to be very reliable. So QT has been our bread and butter business for the past decades, I want to see. It's, in our opinion, the strongest and best HMI platform available that you can use, especially for embedded devices. And so it was natural that we would try to take the voice integration SDK that Amazon provides through GitHub on their website and try to use it in a Qt-based application. So I've already talked a little bit about ICS. We are, as I said, we are a large provider of North America, in North America, where we work mostly in the embedded space. We design, as I said, a lot of medical applications, but we also work in IVIs, we work in control automation. All of these are fields where voice commands are playing a large role these days. So let's talk a little about what we chose Alexa and the Amazon Voice Service as our first point of integration. We wanted to exercise this SDK and find out what you can do with it and go all the way through and really understand it. And then eventually provide a Qt-based wrapper library that can abstract some of the low-level functionality and then use it in an application. That was the goal that we started out with. So when we're looking at the Amazon Voice SDK and the architecture of that, we find that Amazon provides a lot of things as part of their SDK. Some things will happen locally on your embedded device. For example, the audio encoding and sending it up to the cloud, where it is actually being parsed in the Amazon Voice Service, in the Amazon Voice Service cloud instance. And then you get back from Amazon certain things depending on what you said. So when you look at this little graph down here, you can see the audio signal processor and what's called the wake word engine. That is something that is actually on your embedded device. Wake word engines are not provided by the Amazon SDKs because they are proprietary. There are a couple of them that they recommend that you can try. For simplicity, our very first attempt did what is called touch to talk. You just simply press a button, your microphone essentially starts recording, and when there's no longer voice detected, the recording is encoded, sent up to the Amazon cloud service, and they are interpreted and processed. So that's happening. That's what's happening in this shared data stream. So your audio input goes in there. You have the Alexa communications libraries. That runs in the cloud. And basically, what you get back is a JSON blurb, I want to say, a JSON construct. And in this JSON constructs are a variety of directives. And you, as the implementer of your own application, you have to implement what is called a capability agent. So if you want your application to be able to play media, that is as an Amazon music player, like you may have used in your smart speaker, then you have to provide a media player capability agent. If you want to do navigation for an HMI system, you have to provide a navigation capability engine. So there's a couple of them that you have to have that are absolute necessities, and some of them you can just decide not to implement. And last but not least, you have to, the Alexa SDK, the Amazon SDK provides you a focus management library. And with that focus management library, you can, using whatever technology you like, implement UI feedback from the Amazon interaction. So the device SDK is designed to enable developers to integrate this directly into products. All the source code is available on GitHub. It's fairly well documented. It has a modular design and includes a simple sample application that you can use from the command line and try out these services, so you can make sure that all of your connection stands correctly, that your authentication works properly, and so on and so on. It makes extensive use of C++11, not any more advanced features, and the targets that Amazon provides for this are obviously generic Linux and the Raspberry Pi. These are their most prominent development platforms. And then also you can get the SDK for Mac or for Android if you so choose. So we then built essentially a sample application. And this sample application you can actually see in action at our booth in the back of the exhibitor space. We have this integrated into an HMI system. And the way we did it is that we implemented a whole bunch of these manager functions. So from the SDK, you get a default client. There are capability agents, there are connection managers and focus managers. Those we use from that sample application, and then we derive from that additional components. We needed an interaction manager, a UI manager. This UI manager pops up on the screen a notification that something's happened. Or it does what is called speech chrome, what Amazon considers speech chrome, an interaction of what the state of the AVS system is like. So you speak into it, and it's thinking, or it's idle, or it's sending data to the cloud. And so you need some UI feedback back to that. That's what happens here. You also have to deal with authentication engines, and you have to deal with the fact that you need to actually record your data, which on a Linux platform is not necessarily straightforward. The Linux multimedia framework is a bit of a, well, shall I say, a tar pit sometimes for time. Port audio is the library that by default goes into this. After trying for a couple of days, we also had great success with the Q audio input. So we finally made that work. So we no longer actually need port audio. So we wrapped this into a Qt Alexa library in our first version, where we packed everything together. and then we built a sample application with it. So at this point, I have to do a little bit of explaining. There's a difference between smart speaker functionality. So if you have an Echo, you are already able to say, hey, I want to buy some dog food. And if you have your Echo connected to your Amazon account, it'll send you, at least in the US, it can send you pet food. It can send you food for your dogs if you want to. You can buy all sorts of other things. So this is something that's all in Amazon's interest. That's what Amazon wants you to do, right? And so that's all good. That's smart speaker functionality. Smart speaker functionality is also when you say you want to play music and you have your iHeart's Radio, Spotify, whatnot account connected to your Alexa account, all works just smooth and wonderfully. But what if you wanted to say, ask my car to roll down the window in the back, right? What if you wanted to actually do something custom? What if you actually wanted to use the system as a voice assistant? Well, in the standard AVS Alexa SDK, in the actual C++ SDK, there's no such thing. There's no functionality for that, actually. But what you can do is you have to do an extra step. You have to implement a custom intent, right? People implement custom intents for silly little things like games that they play with Alexa, or like little funnies or whatnot. But you can use these custom intents, you can implement custom intents to do things that are not natural, not necessarily, that Alexa wasn't necessarily, that are not integrated. And the reason for that is you may not have the capability as agents, so you have to go around that, right? So that's how this goes. What you do is you develop. First, you have to go onto the Amazon website and develop a custom skills with the Alexa Skills Kit. That's kind of the easy part. That's a web-based interface that you use, and you can actually put a bunch of keywords up, do a little bit of typing, do a little bit of thinking and designing of that, and you develop this skill. But then you actually have to go ahead and implement sort of a client library to interface with the skills service. And then you can do things that when the end result of that is that you can do prefix your request with a skills keyword, right? So you're saying, instead of set the temperature to 75, you have to say, ask my car to set the temperature to 75. This is the restrictions that are currently existing. The newest version of the automotive SDK, I'll speak about that in a little while, is going to remove some of those restrictions. But otherwise, how would the Amazon Voice service know what context your expression was in? So I don't know if this is actually visible from the back. This is just a screenshot of the Alexa Skills Kit to kind of show. And this is actually straightforward. Anybody can develop these skills. Anybody who's ever written 4 lines of Java code or BASIC or whatever can actually do this. So that's not very hard to do. Designing skills is a whole different thing. Doing the mechanical piece of it is easy. Actually making a skill that is actually good and easy to use, that's a whole different piece of art. So this skill interface handles the user interactions, maps it to events in the skills service, and it uses an interaction model, and it basically then the utterances, the utterances of the semantics of your speech will be mapped into intent events, and for that you have intent schemas. So you then have to implement your skill service, and for that you need a web server, an HTTPS server, some JSON response mechanism, an SSL layer for security, and a signed certificate. And you can build all this yourself. And it's actually, if you're experienced in building web architecture, not hard. But of course, you can also just simply use the Amazon service that it coincidentally so provides, and then you just do this in Node.js and running it on AWS's Lambda platform. So this is a fairly simple thing to do, and then we're still not quite there. We're now there that we have a custom intent, we have to recognize it, something happens in the Amazon instance, and now comes another piece of the puzzle that you have to put in place. Because you have to actually get it to do something, right? You have to actually actuate something. If you want the climate controller in your car to actually do something, you have to tell it. And one way of doing it, this is just one way of doing it, but it's a pretty straightforward do, is to take advantage of Amazon's IoT SDK. That's actually a pretty straightforward thing. You can register what is called a device in the Amazon IoT service. And that device, for that device, you essentially have a MQTT instance. The MQTT is a publish and subscribe protocol that is pretty widely used in a lot of industrial applications. And Qt has an MQTT wrapper around it, or you can use the Amazon-provided C or C++ libraries for that. In this case, you would basically let the Lambda function change the value of a device, of an IoT device. That device could, for example, be your rear window actuator, right? And if it's set to 1, it goes up, and if it's set to 0, it goes down. And what you then would do is you basically change that value, and from your application, from the thing that runs in your car, you would actually subscribe to the MQTT topic. And if that value changes, you do something. So if you're then notified using the MQTT mechanism that a value has changed in the cloud, you can register callback for that and then emit your signal, and then whatever happens on your CAN bus or your whatever LIN bus that moves that window up and down will happen. So what you will do, in short, you will have callbacks cause actions in your Qt applications using, preferably, Qt and signals and slots, because that's how it goes the quickest. So this is the overall thing that you have to go through if you want your refrigerator, your baking oven, or your car to be able to do things that are custom with the Alexa voice service. Now, we do a lot of work in the automotive industry, and we were particularly interested in the automotive SDK. So in August 2018, Amazon came and basically said, we have what, so many auto manufacturers we want to get the system into. We've made a specialized SDK just for that. And that is all the Alexa core functionality, essentially, and then there are 4 areas that everybody needs who wants to control their IVI system in the car, namely something about media streaming, which is essentially the same thing as the media player, making sure that if you say, Alexa, I want to hear Led Zeppelin, that Led Zeppelin starts playing, no matter what, no matter where you are. The other thing that you want is navigation. So here you want to do things like find me the next Starbucks, or I want to go home at 6, and I need to go by the pet store. Which pet store has my preferred dog food on sale? You can do things like this with these APIs. You can also then, if you integrate it properly, set the destination of native turn-by-turn navigation systems and so on and so on. So you can also do additional things, local searches, like you want to know where a specific movie is playing, right? So you can say, where's Bohemian Rhapsody playing, or whatever that Queen movie is, at 7 o'clock on Saturday. And not only would you actually, ideally, in the Alexa Auto SDK, get an answer, but you also get a card, what's called a card. You get a little bit of display that you have to put on your monitor that actually shows the location to that, or you can actually route to that. A couple of these things are currently already integrated in our little demonstrator that we're showing in the back. We're working on the full integration of the Alexa Auto SDK, and we'll show a lot more about that at the CES show, where we are working together with the automotive-grade Linux group and Amazon to provide some updates on this. So if any of you guys make it to CES, find the Smart City exhibit and visit the AGL booth, and we can show you some updates on this whole thing. So all in all, what have we learned? What are we going to do next? Well, obviously, Amazon's not the only game in town. There's still also Google Voice. One of the next steps for us will be to look into how this whole thing works with the Google Voice SDKs, and then to see if there are similarities and if there is a abstraction level that it makes a lot of sense to abstract everything to. We have, one demonstrator. We're working on a little bit of an older Alexa SDK. We're going to actually update that And we've already had some preliminary discussions earlier and still want to have them with people here, with leaders from the QT project, to see how we can basically upstream some of our work, make it available to a larger group of people. And and then we want to obviously integrate and use this technology as it gets stronger and stronger to just simply provide better user experiences and make it useful, just as the whole of QT is. So with that, I would like to thank you for your attention, and I'm ready for questions.
Questions? No?
I blew you away, didn't I?
Question? Wow. You gave them everything they needed.
Well, that means it must have been completely clear or everybody fell asleep. So.
I think so, thank you. I think everyone's happy. They now know that they can always have Led Zeppelin in their car.
That's what you want, right?
Yes. Thank you very much.
All right,
Excellent
take care.
presentation.